All right, we are right at 6:30, so we're going to get started. If you just popped in and you saw us chatting, you didn't miss anything at all. We just like to warm up a little bit before our virtual tour of the universe, which is starting right now. Naomi is going to be our pilot, and you should see on your screen the planet Earth. This is a computer program called UniView. Mitch is going to be hosting our event this evening. My name's Jose. I'm going to be monitoring the chat. So if at any point during our program you have a question about something you're seeing, you have a question about a planet or moon, you have a question about something that we're discussing, you can pop that question into the chat. I will try to keep up with those questions. We're also going to be using some polls today, which will ask you to vote. I know we're probably all had it up to here with voting lately, but the polls are quick and simple, and they'll help us decide where we're going to fly in our program today. So with that, without any further ado, I'm going to hand it off to Naomi and Mitch.
And I'm just going to start us off with a quick little PSA. So we're really excited. This week we are opening our all new redesigned Space Odyssey exhibition. It opens to members today and to the general public on Friday. We've expanded it for more than 30%, so it's even bigger than it was before. And it is so inspired by you all, our community, and what you told us you wanted out of a space science exhibit. And so we look at how do we know all these cool things Mitch and I are going to be talking about and so much more in space science. So we're keeping it safe to come visit us in person if you feel comfortable doing that. We're following all of the health regulations, keeping things sanitized for you. And we are capacity limited. So we recommend you check out our website and reserve your timed ticket. It's free with general admission. And if you don't feel comfortable going in person, that's okay. I did a virtual walkthrough so you can get a taste of it, and that is live on YouTube right now. So we hope you'll join us in celebrating this all new exhibit. I know I'm really excited. This has been 4 years of work coming together this week. And with that, we'll turn it over back to the universe.
All right, it's amazing. So we're starting here on many people's favorite planet. This is the planet Earth. And if you haven't been, you should definitely go. It's really beautiful. A lot of great things on planet Earth. Every bunny rabbit ever discovered was discovered on the planet Earth. This is probably where all of you are right now watching this program, is from the planet Earth. And this is the nighttime side, obviously. You can see a little sliver of sunshine on the bottom edge of the Earth. This is, by the way, if you ever look up and see a crescent moon in the sky, if we were on the moon looking at Earth right now, you would see a crescent Earth in the sky. So the part of the moon that's illuminated is the part that the sun is shining on, the daytime side of the moon. So you see up on the north, the top of that, there's all those lights. Those are the cities in North America. I'm pointing, you can't see, but that one over there, that's us. That little bright light. Oh, there we go. Nice. That's us right there. We're that little light. And this is an exciting time because right now, if you have a telescope, you can see all 8 planets and Pluto in the night sky. If you want to see Mercury and Venus, you'll have to wait till right before the sun rises. But right now, every planet that we know of is visible from Earth. And should we jump right to our first poll?
Sounds great.
All right, so 3 of the planets you can see without a telescope, and you could go outside and see them right now. They look like big bright stars that don't twinkle. That's how you can tell the difference between a planet and a star. If it twinkles, it's a star. If it doesn't, it's a planet. So Mars, Jupiter, and Saturn are all up and visible right now, and you can all vote. Which one would you like to go to?
Which one will it be?
Apparently, hosts and panelists can't vote. That's what it said when I tried to vote.
I see some of you putting some answers in the chat. If you can put that in the panel, that'll give us a nice tally, but we'll keep that in mind too when we see the final vote tally. We'll give it another couple seconds here.
These are all places where we've sent lots of spacecraft to. So thanks to that, we've gotten lots of wonderful images that are fed into this program we're using. So we can get a really good idea of what it would look like if our little virtual spaceship we're all riding in together were to fly out near these planets.
All right, I'll tell a quick, really cheesy joke before we close the poll. You ready?
Yes.
What did Mars say to Saturn?
What?
Give me a ring sometime.
Ah,
There you go. Okay.
good one. Oh, sounds like we've got a close race.
All right, let's go and see what those results are.
Gosh, it's so exciting.
Anticipation.
Yes, the suspense is killing me. I hope it never ends.
I'll tell a terrible joke. No, it's the same joke. But do you know why they called it Saturn? They thought it had a nice ring to it.
Oh my.
Oh my gosh, if we're going out into space, I better make sure I'm properly outfitted.
Oh, it looks like it's a tie
Your
between
space
Mars
helmet's on.
and Saturn. Good thing
Oh,
you
an
have the
exact
space helmet.
tie.
And that means that Mitch gets to make the tie breaker.
Oh my gosh,
So much pressure.
Wait,
an exact tie.
I have a coin we can toss.
Oh, let's do that.
I always carry a coin for just this type of situation. Okay. Heads will go to Mars, and tails will go to Saturn. Here we go. Woo. Let's see. Oh, it's heads will go to Mars.
All right. Mars. Mars is the red planet. And you'll see when we get there, it's quite red. But you can even see if you, again, after this program, if you want to go outside and look up into the night sky, Mars is a big bright dot that will actually be a little bit pink. The planet is so red that even from Earth without a telescope, it looks a little bit red. And
if you want to see it tonight, you go out and look to the east in the early evening. That's where you can see it.
yes. And it's named Mars after the Roman god of war, because when the ancients looked up, they were like, maybe it's red because it's covered in blood. It's not covered in blood, but it is red for the same reason that blood is red, and that's a high iron content. And here we are on Mars. Beautiful. It's just beautiful. We have landed, this might be out of date, at least 16 spacecraft on Mars, the latest being the InSight lander, but we have another rover on its way. It is, after Earth, the planet we have explored the most. Oh, and right here, if down at the bottom of your screen, that big pink area, that's not pink, lighter orange area, is the biggest impact crater we see anywhere in our solar system. We think something as big as Mars itself smashed into Mars right there billions of years ago and left that huge dent. So our virtual host, Celine, says, we visited rover and rover again. Good one, good one. So if you have anything you're curious about Mars, please throw it in the chat. I'm happy to just blather on, but I'd love to hear if anyone has something they'd like to know. The different colors on Mars. So Mars is red because it's covered with a dust that has a lot of iron in it. The dust has a lot of iron oxide in it. Now, underneath that red dust, Mars is a lot more similar to the moon. It's a lot of volcanic rock, which is much darker. So those purple areas are where the winds of Mars have pushed the dust away, and you're seeing the dark gray surface with just a little bit of dust over it, making a nice purple color.
We've got a question from Carrie here that says, how long does it take to get to Mars?
Oh, great question. Well, the most fuel efficient way, which is the way we've used every time, is just to push out from Earth so that you get into an orbit around the sun that intersects Mars, if that makes sense. So most of the force we're using is just the sun's gravitational pull. And that takes between usually 6 to 9 months. InSight, the last thing we sent, got there in about 6 months.
Does Mars have any moons? And if so, how did they get there?
Oh, yes. Mars has 2 moons. That's those lines that you see circling Mars. The closer one is much bigger, and it's known as Phobos. And the one is much smaller. It's known as Deimos. They are much, much smaller than Earth's moon. They're not even big enough to be round. They both look kind of like rocky baked potatoes. Deimos looks a little more like a rocky chewed up piece of bubblegum. And they're so small. Deimos is so small that the escape velocity, and by that I mean how fast you have to go to get into space. And so on Earth, I'm going to need someone to check my number here. You need to be going about 25,000 miles an hour.
17,500 miles an hour.
17,500 miles an hour
Okay.
to be fast enough to escape Earth's gravity. On Deimos, you only need to get going about 12 miles an hour. So on Mars's moon Deimos, you could ride a bike off of a ramp and launch yourself into space. So as far as how they got there, we're not sure. They either could have formed at the same time Mars formed out of the same cloud of dust and gases that created the planet, or they could be leftovers from maybe Mars had a larger moon and some collision broke it into smaller pieces, or they could be captured asteroids. The fact that they're both kind of out of the, like in the same plane as Mars's, does Mars have an equator?
It does, yeah. I mean, so they are about the plane of the equator. We arbitrarily define it as the middle. So, yeah.
Okay. So since they're kind of in line with Mars's equator, that suggests that they formed at the same time as Mars out of the same stuff. But if we really want to know, we're gonna have to land a spaceship there and do some experiments.
We've got a few other questions here too about, people have heard that there's ice on Mars, but we don't really see any in this image. And then of course, we also get some questions about whether or not we found any living things on Mars.
Oh, well, if Naomi will fly us to the North Pole, we can see there's quite a lot of ice on Mars.
And I will say, Mitch, this particular image may not show the ice caps particularly well because I think this was taken in Martian spring when the polar ice caps were pretty thin. So we'll see if we can get it show up, but I am not seeing it particularly well.
Okay, well, so Mars is tilted almost the same as Earth, very similar. It's tilted about 25 degrees. So Mars has seasons just like Earth. So in the spring and summer, a lot of the ice melts, and in the fall and winter, a lot of the ice reforms. Maybe we'll get some ice down here on the South Pole, maybe. But despite, oh, there we go. There's the South Pole, ice down there. But there is also quite a lot of ice underneath the surface of Mars. The Curiosity rover found that there's a layer of permafrost underneath a lot of the planet. So there's a lot of ice right underneath the surface. So in theory, maybe if astronauts went there, we could dig up some of that ice, melt it, and have some drinking water, although it might be poisonous. More experiments needed.
And then let's do like one or two more questions before we move on. I'm seeing some questions here about a big volcano on Mars. Some people are calling it Mount Olympus. Maybe we can go check that out.
All right.
I will say I do like how Mars and Earth are so very similar. I think it's really interesting.
And I just wanted to say, on the note of life, we have yet to discover any evidence of life on Mars, but we find a lot of clues that make it seem like we should keep looking. We haven't found anything that suggests that there definitely is life, but there are some things that suggests that maybe life as we know it on Earth could possibly have been there at some point, which would be a really amazing discovery. Okay, so now if you look at Mars, you'll see three little dots in a row and then one big one up above them. They make kind of a pyramid shape if you were to play connect the dots. Those are 4 massive volcanoes. Any one of those volcanoes, if it was on Earth, would be the tallest mountain on the entire planet Earth. And the one on top is the one that people are asking about, Olympus Mons, and it is the tallest mountain we see anywhere in the solar system. It is from its base to the tip, it is more than 3 times as tall as Mount Everest, I mean to say. And it's named Olympus Mons after Mount Olympus, the fabled mountain of Greek mythology where it stretched so high no one could see the top, and at the top all of the Greek gods, including Ares, who was later renamed Mars, lived. Yeah. And actually the first time we sent a spacecraft to Mars that had a camera on it, which I believe was Mariner, was one of the Mariners. But the first time we sent a spacecraft with a camera on it, Mars was in the middle of a dust storm. The dust on Mars is so thin, it's almost more like powder. And sometimes these storms will happen and they can cover most of the entire planet. So the first time we sent a spaceship with a camera, there was a dust storm and we couldn't see anything. Not quite. The only thing we could see was those 4 little dots poking out above the dust, because those 4 mountains are so tall, they stretch out of Mars's atmosphere. So if you were to climb to the top of Olympus Mons, you would be both on Mars and in space at the same time. Yeah.
All right, that's some really interesting stuff about Mars. I mean, Mars is we know a lot about the planet Mars. Like you said, we actually know more about Mars. We know about the bottom of our own oceans. That's because it's easier to get to. And you don't need as much stuff to keep you protected while you're there. But
there aren't as many sharks.
Yeah, not as many sharks. That's right. And then I was going to say is that there's lots of fun places to see in our solar system. And we're going to bring up another poll here in just a second, but we're going to explain it a little bit, because in the new Space Odyssey Reimagined, we have an exhibit about what things in space would smell like. Now, how do we know this? Did we go there and smell them ourselves? No, but certain things have certain smells. Like sulfur is something that has a very particular smell, and sulfur is something that we find out in space. So our next poll question is based on what place you would want to smell. So these are all places that would be kind of smelly. We'll talk about what they smell like when we get there. But that's going to be our second poll for our tour of the universe right now. When it pops up, you might see a gray box on your screen covering up Mars. This is just a byproduct of the computer program that we're using interacting with Zoom, and that will go away once we take the poll out of there. So what smelly place in the solar system would you like to visit? The moon, Titan, which is a moon of the planet Saturn, or Io, which is a moon of the planet Jupiter.
And by the way, these are 3 of the 5 biggest moons in our solar system. And it makes sense that the biggest planets, Jupiter and Saturn, would have the biggest moons, but little tiny Earth, that's us, has the 5th biggest moon in the solar system. We're number 5. We're number 5. Woo!
We're pretty lucky to have the moon too. Not only because it's pretty up in the sky, but also the gravity of the moon has stabilized the spin of the Earth. And that you talked about us having seasons because the Earth is tilted. The Earth is tilted at 23.5 degrees. But without the moon, that tilt would be much more wobbly. So the seasons on the Earth would be probably a lot more extreme. So we're really lucky that we have the moon. Also, the moon acts like a brake because of the tides that it causes in the Earth's oceans and slows the spinning of the Earth down. If we didn't have the moon, our days and nights would be a lot shorter.
Thanks, moon. I mean, seems a little self-serving that it's making the nights longer. Am I right?
Hey, it's coming up in the daytime too. It's a bright object.
Yeah, you can see it during the daytime.
All right. Well, spoiler alert, almost everything in space smells terrible.
Except for one nebula, which we're not going to, and that's okay.
All right, now let's go ahead and get the results of that poll. Ooh, Titan.
Oh, awesome. So just because I'm sure you're curious, our moon smells like a burnt firecracker, like after you light a firecracker, that smell. And that one we do know for sure because the Apollo astronauts tracked it in on their boots into this spaceship and could smell it. Io is covered with volcanoes and has a lot of sulfur, like Jose mentioned, and it smells like rotten eggs. And then Titan, where we're headed now, I forgot what it smells like. What does it smell like, Naomi?
It smells a lot like gasoline. And that is because of what that atmosphere and some of the liquid on the surface is made out of. It's made out of methane and ethane, which we associate with gases here on Earth and would have a smell very similar to the gasoline like your parents put in your car. Or you put in your car, you know, depending on age. Hopefully that teenager's watching.
Listen, my mom still fills up my tank every time.
So here we've got a little, you'll see some variations in texture. When you look at, if you were to take a telescope, like a really good telescope, and find Titan in the sky, you would just see orange. It's got a very, very thick atmosphere that's very hard to see through. But the Cassini spacecraft, which orbited Saturn for a long time, got some better images of some parts of it. So the places where we have more detailed images are layered on there, and the places where we don't, we can't put better images on there. So it doesn't really have those sections like you see in this image. And those big things that look like clouds, those are clouds. Titan is the only other place in our solar system where there are clouds and they rain and they form lakes and rivers, maybe oceans, depending on how you want to define that. But it's the only other place in our solar system where there is liquid on the surface that evaporates, forms clouds, and rains down, which makes it a very exciting place for us to look for some things. I should mention, though, that liquid is not water, because the surface temperature on Titan is an average of negative 297 degrees Fahrenheit, which is much colder than it has ever been on the planet Earth since we've been recording it. The coldest temperature ever recorded on the planet Earth was negative 142.3 degrees, and that was in 1982 at the North Pole. So it's more than twice as cold as the coldest temperature ever recorded naturally on Earth. And of course, at the North Pole, all the water is frozen. Similarly, on Titan, all the water is frozen. There is water, but it forms huge mountains of ice and rocks of ice. And because it's so much colder, it's even tougher than the ice that we have. That's not the right word, but it is a stronger form of ice than we encounter on Earth. So you wouldn't be able to take a normal ice pick and pick this ice. You'd need a bigger one made out of titanium, probably. But I mentioned that it's very exciting that we have this liquid cycle, and that's because there's one place in the universe we know for sure that there's life, and that's planet Earth. And the planet Earth is unique that it has liquid water on the surface, and everywhere on the entire planet where there is liquid water, there's something living. So usually we're looking for water out in space, but maybe it's not water, maybe it's that cycle of liquid evaporating and raining down that creates the conditions that could support life. So this is a very exciting place to look for possible aliens.
And just to dig a little deeper into that science, the reason we need to drink liquid water is because we need the hydrogen in the water in order to break down the foods that we eat and turn them into energy. Now, the methane on Titan it has hydrogen in it. It's carbon and hydrogen, CH4. And so it is a liquid with hydrogen in it. So it possibly could have life that doesn't need liquid water to live. It could live off of liquid methane. But we have to keep studying the moon in order to find out. All right, we're getting some questions here in the chat. Yes, questions about spacecraft. Have we landed a spacecraft on Titan?
So we've landed one probe. The Cassini spacecraft did a flyby Titan and dropped a little probe down there, which gave us our best view of the surface of Titan. And weirdly, if you adjust the color so it's not so orange, it doesn't look that different from something you might find somewhere on Earth. You see rocks and mountains and things like that. There is a spacecraft that NASA is working on to send there, which is very exciting. I sometimes get the name wrong. It's either called Dragonfly or Firefly. Dragonfly. It's called Dragonfly. I don't get it wrong. I know it. It's Dragonfly.
Oh, it's bad.
Which is very exciting because, as I mentioned, there's like lakes and rivers. So Dragonfly hopefully will be able to be a rover that's also a boat and maybe a little bit of a submarine. And the atmosphere is so thick, it could maybe even fly. It's going to be a very versatile all-terrain rover if everything goes according to plan.
And so here's another question for you. Why is Titan orange? Why orange? Why not blue or yellow or green?
Yeah, so this is a question that I had when I became a science educator, because Titan is orange because of all the methane in the atmosphere. Now, Neptune is blue because of all the methane in the atmosphere. And that doesn't make any sense. Although those are the Broncos colors, so yay, Broncos. So on Neptune and Uranus, the methane in the upper atmosphere absorbs all the colors of the sunlight except for blue, which it reflects back. So that's why those appear blue. On Titan, you have a chemical reaction happening where the high energy particles from the sun interact with all of that methane in the atmosphere, and they actually break it apart into smaller molecules. And a byproduct of that interaction is actually kind of an orange smoke. So the atmosphere is full of orange smoke, probably isn't the right word, but orange particulate matter all throughout the atmosphere. And so that's why it appears so orange.
Yeah, it's the same type of hydrocarbons that you find in car exhaust, which is also why smog is orange. And remember, we talked about Titan would smell like gasoline. And so real car-related stuff going on here. We've got a few more questions about Titan. Here's a question that says, how big is Titan compared to Saturn?
Oh, I'm going to pass that question to Naomi, who's better with numbers than I am.
So Saturn is about 9.5 times the size of Earth. It's like 72,000 miles in diameter. And Titan, I'm trying to remember what, I think Titan is about 3,200 miles across. So it is significantly smaller. How's that for a really accurate answer?
Yeah.
That's how astronomers like to say approximately, you know, it's fine, we round. But yeah, 3,000 miles compared to over 70,000 miles in diameter. So pretty small, but still a hefty size moon for sure.
It is bigger than the planet Mercury. And if you were to switch places with Mercury and Titan, then Titan would be a planet and Mercury would be a moon. Largely, those are defined by what they're orbiting, what they're going around.
Also, if you replace Titan with Mercury, most of Titan would probably melt because as it got closer to the sun, the temperature would go up. And since most of the moon is made out of ice, water ice, it would grow a big long tail like a comet and most of it would melt away.
Which would be great. We should do that. So one especially really fun thing I want to say about Titan is the atmosphere is so thick on Titan. It's much thicker than the atmosphere on Earth. And it's so thick that if you could, we're going to make some assumptions, you have a spacesuit that keeps you warm enough and you can provides oxygen, you can breathe. You could put like big wooden wings on your arms and you could flap and you would be able to fly in the atmosphere of Titan. It'd be kind of like swimming through the air. So that's where I think we should send people next.
It would take a long time to get there though. Saturn is pretty far away from the Earth, and unlike Mars, which the trip takes 6 to 9 months, this would take anywhere from 5 to 7 years to get there. So that's a long, long, long trip. All right, let's take 1 or 2 more questions about Titan, and then we'll open up our third poll.
Oh, and I want to acknowledge, maybe I got that wrong. Maybe it is Firefly. Sorry, Yuan, you're totally right. We're wrong. Whoops.
It's Firefly?
Sorry. This happens. Lots of names. This one I will give them is at least creative. There are plenty of spacecraft and things named in space that isn't creative. They're sometimes easier to remember, like the Big Bang, but at least this one is sounding. They're
very long acronyms, like OSIRIS-REx, which is a spacecraft that just grabbed a sample from an asteroid for the first time. Every one of those letters stands for something. And I tried to remember what it was, and I only remember the last part is regolith exploration. That's what the REx stands for.
That's awesome.
And regolith means like ground, soil, not dust, things like that. I guess not technically soil, soil has living things in it. But we're going to go ahead and pull up our third poll right now. So this would be our third destination. And this is a place that is beyond our solar system. So we've looked at places within our solar system so far, Mars and Titan. But through the power of our telescopes, we are able to explore the reaches of space beyond our solar system. So what would you like to visit? A baby star, a nebula, or a pulsar? And a pulsar is what's left over after a star explodes.
And a nebula is a cloud of gas and dust, similar to what we saw in the slides as our intro. That was an example of nebula.
As we were talking about earlier, if you asked the early French astronomer Messier, he would say that all of these are not comets. Which is true. They all are not comets.
They don't move, it's true. Faint fuzzies, though. I mean, when you think about what you see with a telescope and a moderate sized telescope, which is something similar to what we could buy now as quote amateur astronomers, right? Folks that just really enjoy looking at the sky. They really do look faint and fuzzy. And so, especially Mitch's favorite galaxy, the Whirlpool galaxy, kind of looks like it has a fuzzy tail coming off of it. Could have been a comet, but it wasn't moving in the same way.
All right. While we're waiting for that poll result, I see it's an observation from Athena. It says, I have an idea. Why don't we name the next rover coronavirus? That's an interesting idea. It definitely would cement that its place in the universe, but I do think it's not a good idea to go spreading coronavirus around, especially not to other planets. So wear those masks and social distance. But it looks like the results of that poll are in. So we're going to fly off to a pulsar. It was close, but pulsar pulled out on top. And if we have a little bit of time after we look at the pulsar, we might be able to hit a few more places. No guarantees, but we'll just have to see how the rest of our virtual tour of the universe goes.
So the first pulsar was discovered by, oh my gosh, I forgot her name, but a female astronomer, Boyd, I believe is her last name. Oh my gosh, I'm so sorry. Anyway, she was listening to a radio telescope, which if you've ever seen the movie Contact, where there's a huge field of satellite dishes, those are radio telescopes. They pick up the longest wavelengths of light are radio waves. And we can hear them as sound. And she was listening to a radio telescope and she heard this, boop, 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 boop. And she was like, what is that? And since it was so regular and so precise, she decided to call it an LGM signal, which stood for Little Green Men. And at first we were like, is that someone trying to communicate with us? And then we got a better look and it's not. What it is this gorgeous thing that we're seeing right now that looks like a three-dimensional spirograph drawing. But what that is, that little bright spot in the middle is a very, very dense neutron star. This is when a very, very large star explodes, sometimes the remnants will collapse into a very, very small, very hot star called a neutron star. And all these lines coming out of it are the magnetic field of that star, which you can hear from a radio telescope. And it spins very fast. So every time it spins near us, it's kind of like a lighthouse. If you've seen a lighthouse, every time it comes by and you see the flash of light in your face, that's what she was hearing in that radio telescope, was as this pulsar spun, every time one of the poles pointed towards us, it sent that signal of radio waves. And since it sounded like it was pulsing, they called it a pulsar. Because as we discussed, scientists are very clever when it comes to naming things.
Oh, but just wait. The name of this pulsar, which is actually a model of the very first pulsar that was discovered. Are you ready? I don't know if you can handle the excitement of this name. B1919 plus 21. It's based on the coordinates of where it's located in the sky, because we're creative.
So now that star in the middle, I mentioned that it's very, very small and very, very dense and very massive. It's so massive that if you took a single drop of material from that, like in an eyedropper, a single drop of material from that neutron star, it would have more mass than the Great Pyramid of Giza, a teeny tiny drop. Because it's so dense, it has so much gravity, it's just wild.
Yeah, well, here's a question about pulsars. How do we know that pulsars are so dense?
That is a great question, Jose. Naomi, how do we know that pulsars are so dense?
So what we look at is the amount of light that is being given off, what color it is, which can tell us its temperature, and we kind of try and estimate the size of the sky, size it is based on how far away it is and how much of the sky it takes up. And so we know also a fair amount about the life cycle of stars. And we know that a star, before it dies, it starts to kind of puff up and get bigger and bigger, and it starts to shed off layers, creating a nebula. bringing this back full circle to our other objects. And then it doesn't have much energy left to fight gravity. So there's usually two forces in stars working. There's gravity trying to pull everything together as tight as it can. And then there is the process we call nuclear fusion. So this is what makes stars shine. This is what gives them their energy, and it pushes out. And a star is a very careful balance of the two. And when we get something that has been living this long, has burned through a lot of fuel, it's not going to win very well over gravity. So they end up very, very small.
Nice. And I also wanted to mention, just like, have you ever watched an ice skater spinning around on the ice? And when they have their arms out, they spin kind of slow, and they pull their arms in, and then they spin really, really fast. So the same thing happens with pulsars. They were big stars that were spinning at a reasonable speed. And when all of that weight comes in the middle, they spin incredibly fast. So there are pulsars that spin hundreds, thousands of times per second. And I looked it up. That woman who discovered the first pulsar, her name was Jocelyn Bell. So Jocelyn Bell, you should look her up. She's awesome.
So we're getting lots of questions about the magnetic field around pulsar and why there are jets coming out of both ends. Do you want to talk about that a little bit?
I think we should let Naomi talk about that a little bit.
And so this material that is left behind, like we said, was very, very densely packed together. And it is spinning. And spinning things of dense materials like to produce a magnetic field. When you have something really, really dense with some metallic material in it that is spinning very, very quickly, that pulsar signal, that light beam, came around every 1.3 seconds. It's crazy. So we are getting a very strong magnetic field. And when you get very, very strong magnetic fields, and you have some extra material coming out of them, you tend to get jets. And they like to go along the poles of that magnetic field. So imagine playing with a bar magnet, right? There's north and there's south. Essentially, Earth is a bar magnet, as is this star, right? There are field lines that we're seeing here that go from north and go to south. And so it's where those two poles are. We tend to shoot out material, or sometimes we shoot material along those field lines too. But jets tend to happen in space with very, very energetic, very dense objects. We see this in galaxies with objects that are even more dense called black holes. We see this with pulsars. And then we see similar magnetic fields, but at a much weaker level with our planets a lot of the times as well.
That's really cool. Some people are wondering what eventually happens to pulsars.
So they last for a very long time. But in theory, at some point, they'll burn out all of the material and disappear. But we're talking billions of years.
10 to the 7th years, which I need to I'm a visual person. I need to do 10 with 7 zeros after it and sit there. And it is, we get used to using scientific notation. So yeah, 100 million years. So this is going to last quite a long time.
And so one point back in 1977, we launched a spacecraft, the first time we sent a spacecraft with enough speed to get out of our solar system. And just in case anyone found it and wanted to return it, the NASA decided to include a map to get back to Earth. And the way that they did that map was the most consistent, obvious objects we saw in the sky were pulsars. So the map to Earth is our distance from all of the, not all of them, but some of the brightest pulsars that we could see in the sky. Because we thought if you found our spacecraft, you could figure out where we were in relation to those pulsars and come say hi. No one has said hi yet. So we're still waiting.
A few people are wondering, what are pulsars made out of?
Yeah, so the pulsars, it's called a neutron star. So you might remember that an atom is made out of a neutron, some neutrons in the middle, and then electrons and protons gathering around. When it gets this dense, the neutrons all get crunched together in the middle. And so it's mostly very compact neutrons. Fact check, please.
Which are small subatomic particles.
Yeah, and this is a little tricky to think of, like these really, really small things can be really hard to think of in your mind. So we had talked about magnets, and some of you probably have magnets on your fridge. And subatomic particles like electrons and protons, they act like magnets. And I don't know if you ever try to put two magnets together that don't want to go together. Imagine putting a bunch of those magnets that don't want to go together into a bag. A lot of the space in that bag will be just empty space because those magnets, they won't want to go together. But then take something that's not magnetic, like birdseed. You could fit a lot more birdseed into that bag because the little pieces of birdseed don't mind being close to each other. And that's true for neutrons. They don't repel each other like protons and electrons do. They don't mind being close together. And so you can fit a lot more neutrons into the same amount of space that you would not be able to fit. You can't fit the same amount of protons and electrons into that much space. All right.
I saw a question if all stars turn into pulsars, and no, only very, very massive stars turn into pulsars. So like probably a couple,
Not our sun.
100 times bigger than, not our sun. Our sun will probably, when it dies in 5 billion years, don't worry everyone, plenty of time left in our sun. But when it does finally reach the end of its life, it will turn into a beautiful cloud. It'll turn into a gorgeous nebula. But it probably won't leave behind a pulsar or a black hole. Only the biggest stars in the universe create pulsars, neutron stars, or black holes when they reach the end of their life.
Well, thinking of what would happen to our sun, should we take a look at a planetary nebula that might be similar to what our sun looks like?
Sure.
Yeah.
We have a few minutes left before we have to wrap things up. And that was the second most voted thing on our poll. So we can go look at one of those.
And we can keep answering stars while we're or answering questions. Sorry, I read the word star while we're flying over there.
Some people are wondering how far away that pulsar was from Earth. And that's actually really hard for us to figure out. Distances in space can be really, really tricky. And usually we need to see how something is interacting with something else in order to figure out how far away it is. We sort of make a triangle between multiple objects. That's called triangulation. And when you're talking about things in space, they're so far away that making those triangles is really hard, because when you're trying to figure out how far away something is, you look at the angles of the triangle. But the further away something is, the smaller and smaller and smaller that angle's going to get until we can barely measure it anymore. So it's really hard for us to know. We do know that they're so far away that they won't ever be able to bother us. They're really, really far away, but we can't tell you an exact distance in miles because that's really hard to do in space once you really get out of our solar system.
So this star, just to give you an example of how hard it is to determine distances, that pulsar we were just showing you, we think is about 1,000 light years away. But the error bars, how uncertain we are, means it could be 2,500 or 2,500 more light years away, or 760 light years closer. That's huge. And it really doesn't mean a lot because it is far enough away, that triangle is so small and very, very hard to measure.
You can sort of think about it like if you've ever been on a road trip and you look out the window and there's a mountain in the distance, and then closer to you, you see trees zipping by, but the mountain barely seems to move. That you can sort of imagine the technique we use for closer objects. Here's Earth, or sorry, here's the sun, and Earth goes around the sun. Woo! So when we're way over here, we'll take a measurement of something in space against the backdrop of the stars that are so far away, they don't seem to move at all. And then we're all the way over here, we'll take another measurement. And so that's almost 200 million miles apart. And so that's the base of our triangle. And we can find the angle and figure out how far the closer things are away from us. But as Jose said, once they get really, really far away, it's really hard to determine. So this beautiful, oh.
I was gonna say the same thing you were, go ahead.
Okay. This is a beautiful planetary nebula. So you can sort of see that it looks like everything's emanating out from a point in the middle. And that would have been where the star was that reached the end of its life. And the core collapsed and then sort of rebounded and ejected all of this material that was inside of the star out into a big, gorgeous cloud. And this one is known as the Red Rectangle Nebula because it looks like an orange X. It also looks like a red rectangle. And sometimes, not with this one, but sometimes you can find a tiny white dot near the center, which will be the remaining material of the star, usually a little white dwarf star. And since the material seems to be going out kind of in two directions and not in all directions. If it was just a star all by itself, we'd expect the nebula to go out like a bubble was blown from the middle of it. So it's possible that there were maybe two stars in this system, and maybe one of the stars was going around that middle section. And so the material that would be going out in the other directions was gathered up by that star or blocked by it. And the rest of the materials pushes out the other ways.
And I think this one is cool. We're really thankful for this particular visualization from the University of Toledo in Ohio, because this was a scientist who was doing research on this particular nebula and the star in it, and was trying to learn more about it, and took images and created a 3D model of it and shared it with the community of planetariums and museums to be able to put into our planetarium and program like this. So this is really cool. This is a scientist taking time to turn that data, those numbers, into something really understandable that we can fly around and look at and get more information about. So a really cool collaboration here.
Some folks are wondering how many nebula or nebulae, I think.
Oh.
Is that the plural? Nebulae? I'm not sure.
Are
there in the universe? Are there in
okay. Okay, everyone think of the biggest number you can possibly think of. Okay, it's like way more than that. It's an unknowable number. We think that there have been generations of stars. We even think our sun is probably a third generation star. There was a star, it turned into a nebula. Out of the cloud of gas and dust, more stars will form, and then that one exploded, and then more stars form. So there's a repeating life cycle of stars turning into nebulas, turning back into stars, and so on. So we can estimate that in our galaxy, the Milky Way galaxy, there is somewhere between 100 and 300 billion stars. And we are one of probably an infinite number of galaxies. So just really a lot, just so many is the answer.
A good answer.
And there's lots of different types of nebulae too. Nebula is a word from Latin that just means cloud. People have been using it for hundreds of years because they saw things in the sky through their telescopes that reminded them of clouds. And nebulae really are like clouds, but they're not like the clouds in the sky that are filled with little water droplets. They're just filled with lots of different materials: hydrogen, helium, iron, silicon, carbon, all of the stuff that you're made out of, all of the stuff that all of our houses and technologies are made out of, sometimes even water, but not like water you can drink, like little water vapor. And so they really are just big clouds. And some of them, like this one's a planetary nebula, and some of them are huge. Some of these nebulae, some of these clouds are way bigger than our solar system. They have hundreds and thousands of solar systems inside of them. Now that may make you think that if you're in one of these nebulae, you might not be able to see the stars, but actually you got to think of it like when you're in a fog. And I know it doesn't get very foggy here in Colorado, but when you're out in the fog, you can see things that are close to you. It's only when you get and look at things that are far away from you that you can't see when you're in a fog. So that's also how these nebulae work. If you were inside the outer reaches of this nebula here, it'd be really hot because that nebula is really hot, but you'd still be able to see the stars and things. So yeah, these big, huge clouds. And there was an astronomer in the 1700s. Her name was Caroline Herschel. And she was really good at finding nebulae. She found over 1,000 of them. And she got a lot of recognition at a time when a lot of women weren't even allowed to participate in things like astronomy. And so she's one of my favorite astronomers, Caroline Herschel. She discovered a lot of really cool stuff in space.
And working with her brother for a lot of it, and actually discovered a planet as well. So that would be George's
Herschel. Oh, George's star.
George's star, more commonly known as Uranus, but I still like to call it George. I like to think we're on familiar terms.
All right, we've got about 10 minutes left. So if you have a location you'd like to see, pop it into the chat real fast. We obviously won't be able to get to every single location, so we'll see what shows up in the chat and we'll pick one. But this is sort of like a little freebie thing. We've gone through all of our full locations. So let's see if there's another place out there that you folks want to visit. Ooh, lots of really good suggestions popping up here in the chat.
I just wanted to mention one thing. I mentioned that we think our sun is a third generation star. And we think that because of how much gold there is on Earth. Because the only way that gold is created in the universe is in the violent death of a star. So in really big supernovae and things like that, and maybe collisions of neutron stars. There was 2 neutron stars collided a while ago. And when we looked up there, we saw so much gold. So because there's so much gold on the Earth, we were able to calculate back how much time would have passed and how many stars would have had to explode before we could get that much gold.
All right, Jose, you get to pick.
Yeah, we've got lots of really great suggestions. I know a lot of people want to see a black hole, but here's the thing, we don't really have any pictures of black holes. We only have one, and that's because black holes don't let any light escape, and all of the things we use to take pictures need light. So we'll probably pass on that, but I have also seen that a lot of people want to check out the planet Jupiter. So let's fly off to the planet Jupiter and take a close look at the largest planet in our solar system, and it's sort of like its own little mini solar system.
And Naomi, what does Jupiter smell like?
Jupiter actually smells like bitter almonds. Don't smell Jupiter. PSA, if you ever get to Jupiter, don't smell it, because the reason it smells like bitter almonds is due to hydrogen cyanide, which is deadly. But by far one of the least offensive smells in our solar system. So there you go.
All right.
You know,
as we flew in, you saw a huge cloud of little lines. Those were Jupiter's outer moons. And then as we got closer, you saw a bunch of lines all out from the equator of Jupiter that looked kind of like rings. Those were Jupiter's inner moons. Jupiter is the largest planet, and it has, at the moment, the second most moons, because less than a year ago, 20 additional moons were discovered around Saturn, bringing Saturn's number to 82, barely outpacing Jupiter's current count of 79 moons. But I suspect we'll find some more moons around Jupiter before long. So that's what Jose meant when he said it was kind of its own miniature solar system, is that you've got a planet, you've got dozens of moons, and then you've got hundreds of smaller moons, and perhaps thousands more tiny moons.
and if you have a pair of binoculars and you go out tonight to look at Jupiter, you can see 4 of its largest moons called the Galilean moon, depending on how many are up. Sometimes you only see 2 or 3, some are sometimes behind Jupiter. But definitely take a look for some tiny little dots that look like stars coming right off the side of Jupiter. And those would be some of the largest moons in our solar system, including Io, which smells like rotten eggs. So don't smell Io.
And while you're doing that, it's fun to pretend it's the year 1610 and you're Galileo, because he first spotted those moons 1610. It's very exciting.
Does Jupiter have a surface that you can stand on?
That is a complicated question. The surface that we see from here is just clouds. For the first 2,000 kilometers or so into Jupiter, it's just clouds. If you tried to stand on what you see here, you just like if you tried to stand on a cloud floating above the Earth. Then you reach a layer. Jupiter is so massive, the air pressure is so intense that you reach a layer of liquid, mostly the same materials, mostly hydrogen and helium, but compressed with so much force that it doesn't move. So you've got a layer of liquid that in theory you could stand on, but the pressure is so intense that you would get crushed and then just added into the layer. So I guess the answer is no. And then beneath that, we don't know for sure what's happening in the middle of Jupiter, but it could be liquid metallic hydrogen, which until recently was a theoretical material that we weren't sure if hydrogen could exist in that form, but that could be what's in the middle.
And Carrie from Denver wants to know what direction to look to see Jupiter. That is down to the south. So if you look down to the south this evening, you'll see a bright object that doesn't twinkle. That's Jupiter. And to the left of it, you'll see a not as bright object that doesn't twinkle, and that is Saturn. And then if you look to the east, you can see Mars. But we've got lots of questions about the little dots on Jupiter, the storms. How did they get there, and why are they there?
If you see a little black dot traveling across Jupiter right now, that's an eclipse. That's one of its tiny moons casting a shadow on Jupiter. And keep your eye out, lots of eclipses on Jupiter because there's lots of moons. So the little circles and patterns, those are all storms. What's really interesting is so Jupiter, you see how it's kind of alternates between lighter and darker stripes of material. We call those bands and zones. The darker areas are where material is falling down into the planet of Jupiter, and you're seeing sort of deeper in there. It looks like it's flat from up here, but if we got up close, you'd see those cloud tops vary hundreds of miles. And the lighter areas are where material from inside of Jupiter are being pushed up, and they appear much lighter. Sometimes you get to see really deep, and you'll see some blues and things if you can really see deep into Jupiter. So between those bands and zones where material is moving a lot, you'll create those like circles. There's a big one down on the South Pole. These big storms, they're much like hurricanes we have on Earth, huge swirling clouds on the surface of Jupiter. And so on Earth, most of our hurricanes form over the ocean. And then when they make landfall, they'll usually break apart. So Jupiter doesn't have land in the same way that the Earth does. And so these hurricanes can go for a really, really, really long time. The big one, which I think is coming around right now, we see a little bit of it, is the Great Red Spot, which may have been there for over 400 years. Galileo saw something that maybe was that. We've been continuously observing it for over 175 years. But all those circles are massive hurricanes.
Wow, that's incredible. I see that a lot of you still have awesome questions. Unfortunately, we are coming down to the end of our time together, so we won't be able to get to any of those. But you can definitely do your own research. A great place to start is nasa.gov on the internet. They have got lots of wonderful information and cool ways that you can explore the universe. And you can also explore space with the Denver Museum of Nature and Science, not just here on our virtual program, but also in person. We are taking every precaution to keep people safe if you come to visit the museum. And remember, if you are a member, you can go see Space Odyssey now, and it is open to the general public on Friday. You will get a timed reservation that is free with general admission, and there's lots of cool stuff to do in there. You might even be able to fly around the universe yourself in our fantasy spaceship. We encourage you to come and check it out if you are comfortable. Mitch, I love that space helmet, and I love you flying around in space there. It was a great time, so thank you so much for hosting, Mitch. Thank you, Naomi, for being such a wonderful pilot, showing us these incredible visuals. And we want to say thank you to all of you for tuning in and joining us this evening. We love to bring space science to you. We are so grateful that you have continued to stick with us even during this pandemic. We want you all to stay safe. We want you to keep exploring space, keep asking those questions, because who knows, someday you might be doing something like this yourself. There's lots of opportunities to engage with science out there. Thanks again for joining us. We hope you have a pleasant rest of your evening. Goodbye, everybody.
Bye.